Alright, boys and girls, welcome to our third video lesson in Chapter 3, our chapter on exponents and logs. This section 3-3 is on properties of logarithms. Alright, there are three basic properties of logs, and these all have to do with the fact that logarithms are really just exponents. You know, if we multiply two exponents with the same base, for example, if I do x to the a times x to the b, you remember now we're going to multiply those, so we add the exponents, a plus b. Well, it's the same idea now with logarithms. If I take the log of a product, it's equal to the sum of the logs. In other words, log base b x times y is equal to log base b x plus log base b y. If I divide, it's the same thing. This time we're not going to add the exponents, we're going to subtract them, right? So if I had a problem like x to the a divided by x to the b, I would do x to the a minus b. Same thing here with logs. If I take the log of a quotient, so log of x divided by y, it's log x minus log y. And lastly, you remember if I raise an exponent to a power, like x to the a raised to the b power is x to the a times b. Well, the same thing applies once again with logs. If I take the log of a power, so I'm looking right here, I get my pointer. If I take a log of a power, I can bring that power, the exponent, down in front, so it's n times the log of x. Okay, and that b right here, that's the base, that should be here. Okay, so log base b x to the n is equal to n log base b x. All right? Let's just remind ourselves of a couple things. You guys should be asking yourself, what is a common log? It's a log of base 10, right? So it's a log of base 10. What's a natural log? It's a log of base e. And of course, we write that as ln. All right, guys, why don't you stop the tape for a minute and just remind yourselves of these, of your properties of logs, your basic properties of logs. I've filled this little table out here without a calculator, and I'll come back in a minute with the answers. So fill these out, stop the tape. Okay, the answer to the first one is 0, because don't forget, all these first 5 here, these are all common logs, so these have a base of 10. Okay, so 10 to the 0 power is 1. That's why, we're kind of going around here. 10 to the 0 power is 1, so that's 0. 10 to the first power is 10. 10 to the third, of course, is 1,000. 10 times 10 times 10. 0.01 is 1/100th. So 10 to the negative 2 power would be 1/100th, or 0.01. And don't forget, when we have a radical, the square root of 10 is 10 to the 1/2. So log of root 10 would be 1/2. Okay? Down here in the natural logs, the ln's, ln e to the 0 power is 1, so the first one is 0. E to the first is e, so that's why this is 1. And here we have e to the second power, of course, is e to the second. And that you can even see the inverse property in that example right there. Okay? Whip out your calcs. Why don't you stop the tape again, try these with your calc. But before you do that, let's estimate just some of them. Let's estimate some of them. As we look at the first one, we know that 5 is going to be between 0 and 1. Very good. It's between 0 and 1. Log base 10, 5 is between 0 and 1 because log base 10, 1 would be 0. And log base 10, 10 would be 1. And so 5 would be between 0 and 1. In this one, we know must be between 1 and 2 because 25 is between 10 to the first and 10 to the second. It's in between 10 and 100. Think about this one now. Log 0.4, well, 10 to what power? Well, 10 to the negative 1 is going to be 1/10. And 10 to the 0 power is going to be 1. So this is in between 0 and 1. So this is going to be in between 0 to 1. This one would be between what two whole numbers? Why don't you try to figure it out? And maybe a trick question, try this one, try this one too. Do the same thing down here, just try to estimate them and then whip out your calcs. Okay, I just whipped out my magic calc too. You should have gotten log of 5 is 0.699. I'll round to 3 places. Log 25, you should have had 1.40, or I'm sorry, 1.398 if you go to 3 decimal places. Log 0.412 was negative 0.385, and log 765 is 2.884, rounding. Okay, log negative 5, of course, is error. We can't take the log of a negative. The domain of a logarithmic function does not include negatives. Okay, whipping out your calc again and this time using the natural log button. We get ln 10 is 2.303 when you round. ln 35 is 3.555. ln 1.4 is 0.336. ln 0.2 is negative 1.609. And of course, ln 0 is nothing. Doesn't exist. You can't take the log of 0. Can't take the log of a negative or a 0. All right, let's keep it. All right. In your heads, without a calc, because you can't use a calc here, what is log 7 base 7 of 49? Good. The answer is 2 because 7 to the second is 49. What is log base 7 20? Well, we don't know that without a calc. In fact, we could probably estimate that. That's going to be between 1 and 2 because 7 to the first power is 7 and 7 to the second power is 49. So log base 720 must be between 1 and 2. But we're going to learn right now how to find the log of a base other than 10 or e on your calculator because there is no button for that. So we're going to use this formula right here. To change a base rule, log base a of x is equal to the log of any base x over the log of any base a. And so you can use your calc now to figure these out. So we can go forward to find log base 7 4. Okay, we want to find log base 720 before, so let's do that one first. So log base 720, this would equal to the log of 20 over the log of 7. Whip out your calcs. We know we wanted unanswered between 1 and 2, so we're going to do log of 20 divided by log of 7. Make sure you close your parentheses in the right place, and you should get 1.53. All right, let's look at this one, log base 7 of 4. Okay, we know this is going to be less than 1 because 4 is less than 7, right? But let's look at this right now. This is going to be log base of any base, but let's do log base 10. 4 over log 7. Whip out your calcs. Go ahead, whip those out, and you should see that we should get 0.712-ish. Okay, and that is less than 1, as we said. Do you guys try this one? Let's estimate first. We know that this is going to be between 2 and 3 because 5 to the second is 25. And 5 to the third is 125, and 71 is in between. So we know that this log is going to be between 2 and 3. You're trying this right now. I'll just actually wait a second here. Switch colors. All right. So now we get, this is going to be log of 71 over log of 5, and you should get 2.649, 2.649-ish. Okay? Okay, now we're going to do some other work. We're going to do something what's called expanding and condensing logs using our other properties. So as we look at this one right here, this is a single log. We are going to expand this so that we have a series of logs. So I know from my rules that log of a product is equal to log, the sum of the logs. So that would be log A plus log B. So I'm going to look at this and I'm going to say, oh, I have a log of a product, so I have log 4 squared plus log 4 3 to the 4th. Okay, I'm now going to use my third rule and bring the exponents down in front. So I bring that 2 down in front, bring this 4 down in front. So I have 2 log base 4 plus 4 log base 4 3. Okay, this first side we know that log base 4 is 1 because 4 to the first power is 4. So this becomes 2 times 1 or 2 plus 4 log base 4 3. And that we can do nothing with but leave it right like that. If we look at this one, we have the log of a quotient, the natural log of a quotient. So we have using the rule ln or log, but ln A over B is equal to ln A minus ln B. Okay, so I'm going to write this as ln 6 minus ln E squared. I'm now going to use my rule where I can bring an exponent down in front. So I have ln 6 minus 2 ln E, and ln E, of course, is e to what power is e? That would be e to the first, so ln E is 1. So I have ln 6 minus 2 times 1, which is 2. And that is expanded. So this one, you guys can try this one on your own. Just expand this. Very good. We're going to get log, common log, so log base 10y minus log base 10 2. And there's nothing else that we can do with that. Looking at this one, again, we have a natural log of a quotient. So this is going to be ln x minus, now be careful here, ln x squared plus 1 raised to the 1/2. We can bring the 1/2 down in front. So I have ln x minus 1/2 ln x squared plus 1. Can I break this natural log up and say this is 1/2 ln x squared plus ln 1? No, I can't do that, right? We know that we can't break this up. This is as far as we can go. This does not equal that. Okay, so my final answer is going to be ln x minus 1/2 ln in parentheses x squared plus 1. Couple more here. Now we're already expanded. We are going to condense. We're going to condense instead. So I have log base 5/8 minus log base 5t. I'm subtracting log, so I can write that now as log base 5, a quotient 8 over t. And I could stop right there. This one looks complicated. Okay, it's already expanded, so I'm going to condense it. First thing I'm going to do is I'm going to distribute my 4. So I have 4 ln z plus 4 ln z plus 5 minus 2 ln z minus 5. Okay, now I'm going to use my exponent rule and bring the exponents up. So bring the 4's up and the 2's up. Okay, so I have ln 2 to the 4th plus ln z plus 5 to the 4th minus ln to the z minus 5 to the 2nd. And now I have a sum I'll switch colors here so we can see a sum and a difference. So I know I'm going to multiply these two, and I'm going to divide by this guy. So I have ln in parentheses. Up top, I'm going to have 2 to the 4th, which is 16 times z plus 5 to the 4th. Over z minus 5 to the 2nd. Can I cancel those at all? The answer is, of course, no. So there's your final answer. This last one, we just want to simplify. I have log base 6 to some power of 6, and we know that the cube root of 6 is 6 to the 1/3 power. So log base 6 to the 1/3 would be 1/3, because that's our inverse property, but also because 6 to the 1/3 power equals 6 to the 1/3. So my answer is 1/3. Okay, have a great day.